Okay, so what we have here is an automotive supplier, and these are some locations of automotive manufacturing facilities here in the United States. And what we want to do is we're going to create a network, a wide area network, and then local area networks to match this. And then we're going to actually subnet. So we'll start here on the left. We have the Fremont, California location, and it shows a typical LAN segment that you would have in each of these routers throughout this entire network. We are using leased lines throughout this organization. We haven't really specified exactly where we will be bringing internet in, but we'll probably do that in Dayton. So if we look at this, we have two subnets down here, two different VLANs inside of our Fremont location, and one of those is research development, the other is support. We're going to actually have a LAN segment here for our servers, and then of course we have a LAN segment here. And so we've got a total of 4 LAN segments, and those 4 segments are going to be off of each one of these routers that we have here on the right. So we have 40 segments there, plus 41, 42, 43, 44, 45, 46, 47, 48, 49, and we're going to need a segment here. So really we have a total of 50 subnets. And since we are going to be starting using routing information protocol, and we're not going to be able to send our subnet mask out with each segment, then we're going to have to look at the largest segment throughout our entire network here, and we're going to have to make sure that all of our segments are that size or bigger. And if you notice down here on the left, we have a maximum subnet size here of 50. So 50 subnets, each with 50 hosts, is going to be our actual problem that we're going to need to solve. Okay, so let's say that we are given the IP address (170.32.16.0), and that it is a /22 network mask, which means that we would have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So that should work. And what we want to do is we want to split this up so that it covers the network that we need to cover. Now, what we're going to do is we're going to take this CIDR notation address and we're going to break it up further into smaller networks. So what we have here is we have 2 host bits, and then we have 8 host bits here, which gives us a total of 10 host bits. Now, which means that our ranges here are going to, we'll have 170, 32, 16.0 in the first one, and then 18.0 in the second one, and 20.0 and 22.0 and 24.0 and 26.0, and then we'll be at 17.255 over here, and we'll be at 19.255 and 21.255 and 23.255, and then with usable being at 16.1 through 17.254, although we won't use that first one. We'll actually start with 18.1 to 19.254 and 20.1 through 21.254, and then we will do 22.1 through 23.254, etc. And if you need to look at the subnetting scenario, you can look at some of my other videos on that. So what we're going to do is I am going to clear this out here, and each of these routers is going to have for instance, a 20 dot network might be here at Dearborn, and then we would do between Dearborn and Toledo, we would do the 22, maybe we'll do the 24 at Toledo, etc. And so that's how we will be addressing our topology here, and we'll do that in the next video.